This video is to show how to solve a trig equation such as sine theta equals 1/2. So find the angle or angles, there are many of them, that the sine of it is 1/2, or the y-coordinate of the point on the unit circle at the terminal side of that angle is 1/2. So the y-coordinate is 1/2. So when I look at the unit circle, I see that there are a couple of spots where the y-coordinate is 1/2. Either there or there. And so when I'm just looking at the simplest way to land so that my terminal side is there, this one is theta equals pi 6. So when I'm looking at solving this equation, writing what the answer is, I could say, all right, theta is pi 6. But I could land here. And, here's 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6. If I land with the terminal side over there, I've got y-coordinate 1/2. So 5 pi 6 is another solution to this equation. But here's the deal. There's an infinite number of angles that are coterminal with these two angles. So all I have to do is land on one of these two spots, and I'll have the y-coordinate equal to 1/2. And there's so many ways to do that. For example, I could start here at 0, go around, start here at 0, go around the circle one time, add another 5 pi 6, and that's pi 6 plus 2 pi times 1. Or I could go around the circle a couple times, and then that extra that extra pi 6. So that's pi 6 plus 2 pi times 2. Or I could go backwards a couple times, maybe 3 times, and then that extra pi 6. And that's pi 6 plus 2 pi times -3. All of these will land at this spot that has a y-coordinate 1/2. So how do I write that? How do I write that so that I'm encompassing all of the times when I landed there with an angle coterminal to pi 6? And the standard way to do this is to say, okay, pi 6 plus any integer multiple of 2 pi. So I say 2 pi times some number where I make sure that k is an integer. I can't say k is 1/2 because 1/2 of 2 pi is just pi. And if I had pi 6 plus pi 6 plus pi gets me over there. Well, I don't want that. That's no good. So I have to have a full rotation, a full integer multiple of 2 pi. And that will do it. So similarly, I could say 5 pi 6 plus go around the circle an integer number of times. So this is the way to write all the solutions between 0 and 2 pi. And then here's all solutions, the infinite number of solutions.